This is the heavy lever bow experiment, except the heavy lever bow is going to be so heavy it would be unworkable to experiment on. So I made a thin slat of ash, put some levers on, pulled it, and it all worked, but the draw weight was so light that I wouldn't be able to get a decent force draw curve. So I don't know if you can see, I added a thin slat of ash to the back, and that's brought the draw weight up nicely, almost making it impossible to brace. So I'll put like a long string over the tips to enable me to pull it back far enough to actually brace it. So I can now take this off. Just hang that on there. This was cunningly done with nice long loops. A bit like one of those topological puzzles. How do you get two interlocked things away from each other? Right, there we go. So, like I said before, I don't know what the tiller's like. It doesn't actually matter that much. In fact, this looks to be the slightly stiffer side. I'll turn it round just for the sake of argument, because I normally have lower limb to the left. I also normally have me magic toggle to the right. So anyway, we'll pull this now, and it will either explode or it might work. I think I'll just shift it slightly over. I want it to try and come off both levers simultaneously. So there we are, we're up at 30, not quite to the end, not quite coming off the levers. There, she's just about thinking of coming off the levers there. Christ, that's working pretty hard, isn't it? There, it's just lifting off the levers. Oh, that's working hard. I'm tempted to relieve it a little bit there, just to get it bending a bit better. So I don't want to try and get a force draw curve and have it explode. It's only £40, isn't it? Let's do a force draw curve. Right, I've got my digital scale on it, and rather than writing down results, what I'll do is I'll call it out. So it'll be on video, and then I can draw a graph afterwards. Hopefully it doesn't all go bang and fall on my head. And at least the string bridges are sort of doing their job, because it's a bit on the twist. Right, so 8 inches, 2.5 pounds, 9 inches, 5.9, 10 inches, 9.2, 11 inches, 11.8, 12 inches, 14.5, 13 inches, 17.5, 14, 20, shit, giving me the willies, 15, 22.5, 16, 25.1, 17, 27.8, just I'm going to the nearest single decimal point, 18, 30.5, 19, 33.4, 20, 36, 21, 38.6, 22, 39.5, 23, 40. Christ, it's twisting like mad, it's in danger of popping off. So I'll be able to plot that, but it shows you the problem with levers and instability. So I can shape the edge of the lever to push the string back that way a bit and maybe redo the test, or if it's coming, it's twisting towards the weak side, I can take some off that other edge. But basically we've got something I can experiment with to get some sort of figures, get some sort of idea. But I think it shows how much effort it would be very easy to waste if I went straight on to building a heavy one, because all this, it's so twitchy and experimental. But I'm enjoying it. Right, to help counteract that sideways bend, what I've done, I want to move the string this way, so I've actually flattened off that edge so I can just splice another bit of timber on so I can move the whole tip over towards this side, just reshape it a little bit at a time so I don't go and overdo it, because the problem is if you're slightly offline, that leverage pulls it more and more offline, and it just gets worse and worse. So make haste slowly, grasshopper.